Hi guys, a very good evening everyone. Welcome all of you to this session. Welcome to Om Institute once again. All right. Just a second. Yes, good evening Amarjeet. Good evening Hovant. Very good evening everyone. Right. Just a second. Yeah. So I think the audio and all looks good. Okay, you can let me know if there is any issue, but I think the audio and all seems good for me. Okay, so finally let's get started. Very good evening once again everyone. Okay, welcome to this special session because GATE examination is now closer and MSQ is the new trend of the examination. Okay, the MSQs are being discussed in the asked in the GATE examination from 2021 onwards, and mathematics is one such subject where definitely MSQs are coming up mostly. Okay, and let me tell you, last year MSQs are there in every branch from maths, especially in EE, around 4 to 5 MSQ only maths. Last year, 2024 examination in EE, 4 or I guess 5 MSQs only in EE from only mathematics. Okay, 2 to 3 were there in EC also from mathematics, and similarly in all the branches it was there. Okay, so today what I'm going to do is, okay, collecting the MSQ questions from 2021, because 2021 we introduced, the IITs introduced the MSQ pattern. From 21 to 24, okay, MSQ question of engineering mathematics. Let's start discussing on topic to topic basis. So quickly update all your friends that the session is do live. If anybody wants to join, they can join it now. And here it is. Moving ahead to the first information and then towards the first question. Guys, tomorrow is 12th of January. Okay, tomorrow is 12th of January, and do not forget that yes, tomorrow you do have a All India GATE 2025 mega online mock test. Okay, and this is for EC and EE, and as per the exam times of EC and EE, so EC and EE GATE official time is 2:30 p.m. to 5:30 p.m. and exactly on the time the mock test will be conducted. There is also exciting gift for the top 5 performance of the examination, and all students will get the all India ranking, the real time experience, and the detailed explanations of all the questions will be provided. Okay, the registration is mandatory to appear in the exam. Exam is free and also registration is free, but for free registration you can just scan this QR code and get yourself registered. Right. And also guys, as per the students' demand, the mega marathons are there for you. Yes, guys, the revision mega marathons. Okay, as like a New Year gift for the GATE 2025 aspirants. Okay, so what are the upcoming plans for the GATE aspirants? Okay, all those upcoming plans, all the revision mega marathon updates and everything, and few more important things we are going to tell you tomorrow. Okay, to begin up the marathon. Okay, so let's connect tomorrow at 7 p.m. Tomorrow at 7 p.m. join with the entire team of home. Okay, and get all the useful information. Okay, and the beginning of mega marathons as well. Right, tomorrow 7 p.m. Tomorrow 7 p.m. So this is the first question for you. Just a second. I hope I have done one important thing. Yeah. All right. Yes, guys. So the first question, PNQ Hello, 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 hello. Yes, yes, guys. The sound would now be there. It was a battery issue. Okay, it was a battery issue, but now the sound would be there definitely. All right, yes. So if they are invertible, how the multiplication goes? PQ whole inverse is Q inverse P inverse, and then definitely QP whole inverse will be P inverse Q inverse. This is also correct. If they are non-invertible, okay, if they are not invertible, what about option number D, dear? Okay, definitely A and B are correct. Okay, PQ inverse will be reverse Q inverse P inverse, and QP inverse will be P inverse and Q inverse. If they are non-invertible, so inverse doesn't exist. So there is nothing that we can talk about option number D. Okay, we cannot use Q inverse, we cannot use P inverse if the matrices are non-invertible. Okay, so matrices should be invertible. What is the condition for invertibility? They are square matrices, that is number one condition, and invertible means the determinant of the matrix should be non-zero. Okay, it's a direct property question, I would say, right? Okay, it's a direct property question. Is there a lag? Determinant of the matrix. Yeah, correct only, correct. Audio is there. Yes, guys, next question. The next question for you. The system of linear equations in xy is given by, okay, on system of equations, it is given by xy equal to 2, 5 minus 2 alpha, alpha 1, okay, equal to 0, 0. What are the equations? Oh, sorry, this is multiplication. I think that's a typo error. These two are multiplied. Okay, so when you're going to multiply them, how the multiplication will look like? So see, first row with this column. So what is the first equation? 2x plus alpha y. Okay, equal to 0. And next, this first row with the second column. So 5 minus 2 alpha multiplied by x plus 1 into y, that is y, equal to 0. Okay, so you have a homogeneous system of equation. Okay, you have a homogeneous system of equation. Something like ax equal to 0, you have a homogeneous system of equation, correct? You have a homogeneous system of equation. And now the next part of the question says it involves a real parameter alpha. The alpha is real and has infinitely many non-trivial solutions. So what is the condition for a homogeneous system to have non-trivial solution? Okay, for non-trivial solution, det A should not be equal to 0. Oh, I'm so sorry. Determinant A equal to 0 for non-trivial solution. The determinant equal to the 0. Okay, for infinite or non-trivial solution, determinant equal to the 0. Okay. Okay, Sandeep, we'll check it out. Let's continue with the question right now. Okay, so in a determinant A equal to 0. So what is the determinant? 2 alpha, 2 and alpha. This is 5 minus 2 alpha and 1. This determinant should be equal to 0. So solving this determinant 2 and minus alpha into 5 minus 2 alpha. This must be equal to 0. So 2 minus 5 alpha and plus 2 alpha square equal to 0. So leading you towards a quadratic equation. Okay, what is that quadratic equation? Let me rewrite it here. 2 alpha square minus of 5 alpha and plus of 2 equal to 0, leading to the values of alpha, which is minus b root over plus minus root over b square minus 4ac. Okay, the 4 4s are 16 is divided by 2a. Is divided by 2a. So alpha is under root of 9. So 5 plus minus 3 by 4. So 5 by plus 3, 8 by 4, 2 and 2 by 4, 1 by 2. These are the two values of alpha. Correct. Now, if these are the two values of alpha, dear, keep listening. If these are the two values of alpha, how the equation will look like? Okay. For the first set of alpha, alpha is 2. Okay. If I take the alpha equal to 2, first condition. Okay. How the equations will look like? What is my first equation? 2x plus 2y. Alpha is 2. Now, the 2x plus 2y equal to 0 because my equations were, let me rewrite the equation here also, 2x plus 2 alpha, 2x plus alpha y equal to 0, and next equation is 5 minus 2 alpha into the x plus of y equal to 0. So I have alpha put 2. So then next, if you put alpha equal to 2, the 5 minus 4, 1. So that is second equation will be x plus y equal to 0. And actually both are similar only. If x plus y is 0, the 2x plus 2y automatically is 0. Clear? Okay. So if alpha equal to 2, this is a set of equation. Combining them, we have only one equation actually, x plus y equal to 0. So which of the option can be correct for this value of alpha? Okay, the x plus y equal to 0. Option number A, the sum of x and y should be 0. Not B, not D, and not C. Okay, so this goes with option number A, and it is the MSQ question. So Maybe one more option is correct for another value of alpha. We have another value of alpha, and what is that another value of alpha? I have got another value of alpha as 1 by 2. Okay, putting that another value of alpha, my first equation will be 2x plus alpha y. So alpha is 1 by 2. So plus half y equal to 0. And second equation would be 5 minus 2 alpha. Alpha is half, so 5 minus 1, 4x plus y equal to 0. Again, it is one and the same thing only. Okay. That is the condition for non-trivial solution, right? That is the condition. This is what is the system Ax equal to 0. A means the coefficient matrix where you combine the coefficients of x and y, stranger, right? So these coefficients 2 alpha, 5 minus 2 alpha and 1, they form the A matrix. Okay. Now dear, so again this is the same thing, that 2x plus 1 by 2 y equal to 0 multiply by 2, 4x plus y equal to 0. So what option can satisfy here? Let's take the simple number, 4x plus y should be 0. 4x minus 4 plus y 0, satisfying. 4x plus y not equal to 0. 4x 16 minus y not equal to 0. So here B option will satisfy. So two options are correct, A and B. Hovan, very correct answer. Yes, so two options are correct. That is option number A and B. The two options which are correct here is the option number A and B. And now I will go towards the next question. Okay, here it is. Towards the next question, here it is. Okay. If A is the 3 cross 5 real matrix of rank 2, for the set of homogeneous equation Ax equal to 0, where 0 is a 0 vector and x is a vector of unknown variable, which of the following is or are true? Which of the following is or are true? Okay, is or are true. Okay, so see, again this is a question on homogeneous system of equations. Again this is a question on homogeneous system of equation, Ax equal to 0. Okay, Ax equal to 0, homogeneous system of equation. Okay, A is the 3 cross 5 real matrix. Now dear, A is a 3 cross 5 matrix, or whenever you say A is M cross N matrix in linear system of equation, what is this M? What is this N? Okay, N. Okay, the number of columns of matrix A is always equal to the number of variables, and M is equal to the number of equations. The number of rows of the matrix A correspond to the number of equations. Right. Now, x is a vector of unknown variable. Which of the following? Acha, what should be the size of x? Now, because A is 3 cross 5, for the multiplication to happen, okay, for the matrix multiplication to happen, x is 5 cross 1, or more generally, let me say x is always n cross 1. X is what? X is a vector containing unknowns. How many unknowns I am telling you? N number of variables. So n cross 1. It will be n cross 1. Correct, dear? That will be A matrix n cross 1. X matrix n cross 1. Okay. Now, will the given set of equations have unique solution? Okay. Now, A is not a non-square matrix, so we can't talk about determinant. Okay. We can't talk about determinant. Okay. What is the condition for unique solution or trivial solution? This is again homogeneous system of equation. Okay. For the homogeneous equation Ax equal to 0, okay, it will have unique, or meaning trivial in case of homogeneous, that is also known as trivial solution. Okay, if the rank of the matrix A equal to n, equal to number of variables. Okay, and if rank of A is less than n, then the system has infinite or non-trivial solution. Infinite or the non-trivial solution. Infinite or the non-trivial solution. Correct, dear? Okay, that is what is the condition if rank of A less than n. Okay, hope you remember all these conditions. Okay, if rank of A less than n. Now you see, what is the rank of A given? A is a 3 cross 5 matrix of rank 2. Okay, rank of A equal to 2, which is less than the number of variables. So it will have definitely, it cannot have unique solution. It will have infinite or non-trivial solutions. It will have the infinite or the non-trivial solution. So A is wrong. The given set of equation will be satisfied by a 0 vector. See, this is also correct because homogeneous system of equation, x equal to 0 is always a solution. Correct? That is the first thing we should know about homogeneous system of equation, that x equal to 0 is always a solution. X equal to 0 is always a solution. So the given set of equation will be satisfied by a 0 vector of appropriate sides. Appropriate sides here will be 5 cross 1. B is correct. Given set of equations will have infinite many solution. Yes, correct. Given set of equation will have a finite many but finite. That is impossible. See, either a system will have one solution. If it is having more than one, it will be infinite only. You will never have a system, whether homogeneous or even non-homogeneous. You will not have a system having 5 solutions or 10 solutions. If more than one, it is always infinite. So the correct options here will be option number B and option number C. These are the two appropriate options. Correct, Hovant. Option B and the option C. These are the appropriate option. Now the next question is ready for you. For the matrix, which of the following options is or are true? Which of the following statements is or are true for the given matrix? Okay, whether it AX equal to B non-homogeneous system of equation, whether it has a unique solution, whether it does not have a unique solution. So because it is only about unique solution, A is a square matrix. Okay, yes, Joshna, correct answer B and C for the previous. A is a square matrix, so only determinant of A will be sufficient to at least conclude, okay, on the uniqueness of the solution. Determinant A is how much? Let me start expanding along the first row. So 1 into 2 minus 1 and minus of next is minus 1 number, and its minor correspondingly will be minus 1 minus 0. Okay, so 2, this is minus 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 only. Correct. 1, determinant A equal to 0 actually. Determinant A equal to 0. 1 minus 1. 1 minus 1. Okay, determinant A equal to 0. If determinant A equal to 0, it cannot have unique solution. Now this is a non-homogeneous system of equation. If they further ask, see, if the system does not have unique solution, then it may have infinite solutions or no solution. If they further ask whether it will have infinite or no solution, then we need further analysis about ranks and all, but right now not required. For unique solution, it is simple condition, determinant A, if not equal to 0, system will have unique solution. If determinant A equal to 0, system cannot have unique solution. Okay, so it cannot have unique solution, at least B is correct. Okay, it will have 3 linearly independent eigenvectors and A is a positive definite matrix. For both these options C and D, for both the options C and D, we need the eigenvalues, and it's a 3 cross 3 matrix. Okay, what is the 3 cross 3 matrix characteristic equation? The shortcut that I have taught you earlier, if you have followed the earlier classes. Okay, so what is the 3 cross 3 characteristic equation? And normally the characteristic equation is determinant A minus lambda I equal to 0, but for 3 cross 3 we consider it as lambda cube minus beta 1 lambda square plus beta 2 lambda minus beta 3 equal to what? Equal to the 0. Okay, so lambda cube minus beta 1 lambda square. Now what is beta 1, beta 2, beta 3? The calculation, beta 1 is equal to the trace of the matrix A, sum of diagonal elements. So what is the trace of the matrix A? 1 and 2 and 1, if I add them, 1 plus 2 plus 1, so it is equal to the 4. Okay, it is equal to the 4. Then what is beta 2? Beta 2 is known as the sum of the minors of the diagonal elements. Beta 2 is known as the sum of the minors of the diagonal elements, correct? Beta 2 is known as the sum of the minors of diagonal elements. So what is going to be the beta 2? What is going to be the beta 2? So for every diagonal element, first diagonal element, the first row, first column deleted, to 2 minus 1. Okay. Plus, then second diagonal element, second row, second column deleted, to 1 minus 0. And third minor corresponding to third diagonal element, corresponding to the third, this is the third diagonal element, third row, third column deleted, then what is this determinant? 2 minus 1. Okay, so all are 1, 1, 1. Final answer, beta 2 equal to 3 and beta 3 is equal to determinant of the matrix A, which we have already calculated as 0. The determinant of the matrix A is 0. Okay. Right. Now, feeding these values in the characteristic equation, how the characteristic equation will look like. Let me now check how the characteristic equation finally will look like. My final characteristic equation, lambda cube minus beta 1. What is beta 1? 4. 4 lambda square plus beta 2 lambda. Beta 2 is 3 plus 3 lambda equal to 0. There is no beta 3. Beta 3 is actually 0. Okay, so taking the lambda common, lambda square minus 4 lambda plus 3 equal to 0. Further factorize this as lambda minus 1, lambda minus 3. Done, na? 1 and 3 will add to 4 and 1 into 3 will be 3. So what are the eigenvalues? 0, 1, 3. This is the set of eigenvalues. Option number C and D depend both on the eigenvalues. Now, what is option number C? Matrix A has 3 linearly independent eigenvectors. The number of linearly independent eigenvectors, okay, the number of linearly independent eigenvectors is equal to what? It is always equal to the number of distinct eigenvalues. It is equal to the number of distinct eigenvalues, and all three are distinct actually. All the three are distinct. Okay, all the three are distinct. Yes, so matrix will have 3 linearly independent eigenvectors, correct. Whether A is a positive definite matrix. What is a positive definite matrix? Positive definite matrix is a real symmetric or a Hermitian matrix. Real symmetric or a Hermitian matrix. Okay, such that all the eigenvalues are strictly positive, are greater than 0, strictly positive. A matrix is said to be positive definite, okay, if it is the real symmetric or Hermitian, any of the matrix, such that all eigenvalues are strictly positive. All eigenvalues are strictly positive. So what is the condition here? We can say that lambda is greater than equal to 0 and matrix is symmetric. Yes, you can see that elements above and below the diagonal, -1 same, 0 0 same, -1 same. What is given to you? This is a real symmetric matrix. Real symmetric matrix. Okay, lambda greater than equal to 0. We call that the matrix in such condition is positive semi-definite. It is not positive definite. It is said to be positive semi-definite. Okay, so option number D will go wrong, but what is correct till now? It will not have a unique solution and it has 3 linearly independent eigenvectors. B and C are the correct answers. The final correct answers are B and C here. Okay, dear? Okay, the final correct answer B and C. Yes, Hovan, recheck the eigenvalues, I think once. Okay, the final correct answer B and C. Absolutely correct. Moving ahead to the next question. Moving ahead to the next question, right? Okay, so several variety of concepts we'll keep learning one by one with these questions. Okay, yes, next question, dear. Let's move ahead to the next question. Yeah, okay, GATE 2024 current year 2 marks question. It's a GATE 2024 current year 2 marks question. Let's see what is the answer to this question. What is they are asking in the question? Consider this matrix 1k 2 1 where k is a positive real number. Which of the following vector is or are the eigenvectors of this matrix? Which of the following vectors is or are the eigenvectors of this given matrix? Which of them is or are the eigenvectors? Okay, stranger, good to know that. Yes. So which of the following vector is or are the eigenvectors? So normally eigenvectors, 2-3 times I have seen from the eigenvectors MSQ question coming up. This is the current year example. Okay, so now eigenvector. Eigenvector is a vector which will simply satisfy Ax equal to lambda x. That means if x is an eigenvector, A into x should be proportional to x. Okay, lambda into x. Lambda is any number and that lambda is actually known as eigenvalues. Okay, marks is not visible. It is there, 2 marks. Previous one is 1 mark. Matrix is not visible. Here the matrix is visible. This is the given matrix. I'll rewrite here, not a problem. Okay, the matrix A given to you is 1k 2 1. This is the matrix 1k 2 1. Correct? Now we have to go option by option. Suppose option number A is correct. Suppose the option number A is correct. Okay, rather than finding the eigenvectors, it is easy to cross verify the option. A into x, 1k 2 1 multiplied by x. What is x? Root over 2k and minus 1. Root over 2k and minus 1. Okay, so let's multiply this. The first is root over 2k, first row, first column, and then minus k. minus k, and then 2 root 2k, 2 root 2k and minus 1. Okay. This is what is the option available in front of me. Okay. This is what is the option available in front of me. Now, can you convert it something in the form of the given matrix? Somehow, can you write this in the form of given matrix? A given vector ax should be equal to lambda x. Correct? 1k, 2, 1 and root 2k and minus 1. Correct? I have multiplied it. Somehow, can you convert this? Somehow, can you convert this by taking anything common or so? Okay. If I try option number B, let's keep moving first of all. If I take ax, 1 and k and 2 and 1. And now what is the option number B is root 2k and plus 1. Root over 2k and plus 1. Okay, here 1 into root 2k, first element and plus k. And then the next row 2 root 2k and plus 1. Okay. Can you somehow simplify it? Okay. Option number C. A into x, 1k, 2, 1 multiplied by how much? 1 root over 2 by k. See, now 1 then plus k into root over 2 by k. So root k cancel. 1 root 2k will come in the numerator. Then 2 and plus root over 2 by k. Okay. See, the idea is, the given vector is root 2k and minus 1. Okay. Or suppose, let me start with the B option. Okay. B and A are so almost similar, a plus or minus difference only. Root 2k and 1. Okay. Here 1 should be left. And to take the 1, you should take this entirely common. 2 root 2k plus 1. But if you take it entirely common, okay. If you take it entirely common, how the root 2k will be left here? Okay, what you can do is, even if you want to take k, common from here, okay, so then 1 by k will be left here. No, you cannot relate that. But look into the C option, understand the calculation. If you look into the C option, okay, I want 1 here. 1 means let me try to take this common. But is this entire term common available here? Now you see here, 1 plus root 2k, this is 2, na? Okay, this is 2. Suppose, any number can be taken. I want to make it as 1. Okay, first let me try to take the 2 common, root over 2 by k. So better let me take the root over 2 by k common here. Root over 2 by k. I am taking common here. Okay, then what is the answer left? 1 left here, and what should be left here? Okay, what should be left here? I have taken root over 2 by k, which was not available. So I will divide by root over 2 by k. Okay, so 2 by root 2 going above and k going above. So yes, exactly you get this term root 2k. See, these two multiplied will give you the correct answer. Now, what can I say? I have a factor 1 plus root 2k common. I have a factor 1 plus root 2k which I take common. Then what is left inside? This is totally outside to 1 and then root over 2 by k. Okay, which is my applied vector x. So this option ax satisfies lambda into x, where lambda is this number. Lambda can be any number, na? This is the lambda number. So C option is correct. That is what I was trying to tell you. Can you do it for option number A or B both or any of them? Okay, that's what I'm telling. If you have to make one here, okay, somehow, okay, suppose if you want one here, if you take k common, okay, if you take k common from here, so here root over 2 by k will come, which is not going to match here, okay, which is not going to match up here anyways. Okay, but C option matches it. Let me try for D option then. Okay, so at least C is correct. Now D, 1 and minus of root 2 by k. Okay, so D option AX, A matrix is again 1 and k and 2 and 1, 1 and only the minus sign difference. Let me multiply it. So first 1 and then only a minus sign difference will come, minus over root over 2k and then 2 and minus of root 2 by k. Once again, I'll try the same calculation that from the denominator term, okay, from the denominator, I'm trying to take root over 2 by k common. Okay, from the second term, root over 2 by k common, or actually minus of root over 2 by k common. If I take the minus of root over 2 by k common, okay, so this term will actually become minus And what will be the same 2 upon root over 2 by k, root 2k will come up here. Okay, minus of root over 2 by k, and this was completely taken outside, so plus 1 will be left. Okay, and now you see the above term. Now you see the above term, which is also 1 minus root over 2k. Okay, so this answer is, okay, what I'm going to take outside now, 1 minus root over 2k outside, whole multiplied by 1 minus of root over 2 by k. Okay, and now again I am able to match ax equal to lambda x. This was the x applied, the same x I got, this is the lambda. So D also correct. D also correct answer, right? Hi Mohan Babu. So what are the options that is matched? D and C. What are the options that is matched? D and C. The options that is matched is D and C. Okay, hope that is clear to you. Let's move ahead to the next question then. D and C. Next question. Okay, again guys, same eigenvector, only it is a 4 cross 4 matrix, maybe little calculative. So similar model question I'll give you as homework, but I'm telling you eigenvectors 2-3 times. Okay. You can assume value of k also, not a big deal, Ricky. So what I'm telling is eigenvectors have produced MSQ questions 2-3 times. So this is the same model question, same approach you have to try. Okay, same approach you have to keep trying. Ax equal to lambda x. With numbers it will work. Only thing is size becomes more, but with numbers it will become actually more simple. Only thing you have to calculate correctly. Okay, so I'll give you this as homework. Okay, try calculating, and later on once you complete, please answer in the comment box. Please answer in the comment box. Next question. Next question. Gate 23, 2 marks question. 2 marks, but a direct statement question actually. Direct statement question. For the matrix A, which of the following is statement is or are true? Eigenvalues of A transpose same as eigenvalue of A. It does not mean that you have to sit and calculate. You have to sit and calculate eigenvalues of A and A transpose. See, some standard results. Okay, some standard or important results. Okay. If I say matrix, corresponding eigenvalue and corresponding eigenvector. This is actually important result, so I'm writing different cases out of it. I'm writing the different cases out of it. So what is the matrix? Suppose A, it has eigenvalue lambda, eigenvector x. Okay, if you take A square, A cube or any A power n, any matrix A power n, the eigenvalue will be lambda power n, same eigenvector. Same eigenvector. Okay. Same eigenvector. Some answers are already started coming up. Let's take it out. Okay. Then similarly, you can take n negative also. A inverse. A inverse will have the eigenvalue lambda inverse. That is 1 by lambda, same eigenvector. Or if you take A plus I, A plus identity, eigenvalue will be lambda plus 1. Plus I in the matrix, plus 1 in the eigenvalue, same eigenvector. Or if you take K into A, any scaling, matrix multiplied by k, eigenvalue also multiplied by k, same eigenvector. That means if you basically take any function of A, if you take any function of A, you get the eigenvalue as the function of lambda, right? As a function of lambda, basically. That is important result. Okay, but some more cases, like if I say A transpose, okay, it will have the same eigenvalue as lambda, but eigenvector cannot be commented as a property. Eigenvector cannot be commented as a property. Okay. Okay, these are some of the results that must be known to you. Okay, so eigenvalues of A transpose are same as eigenvalues of A, 100% correct. Eigenvalues of A inverse are the reciprocals, that's what I told you, yes. Eigenvectors of A transpose same as eigenvectors, no. Eigenvectors of A inverse are that same as eigenvectors of A, correct. So ABD, correct answer ABD, yes, correct answer. Hovan check, not C, it has to be B. Eigenvectors of A and A transpose are not generally same. Okay, they're not the same. Okay, if Ax equal to lambda x, A transpose x will not be equal to lambda transpose x actually. Okay, so hence it is the result I am telling. Okay, so A, B, D are the correct option. Moving ahead to the next question. Gate 22 1 mark question on the similar concept actually. See, I told you, na, the matrix M is given to you and it has eigenvalues. See, for a 2 cross 2 matrix, you can calculate eigenvalues, but still they have given it. Still they have given it. Okay, so again, that means they want to test the property. Okay, now there is some matrix Q given. Okay, there is some matrix Q given, which is some function of the matrix M. M cube minus 4M square minus 2M. What are the eigenvalues of the matrix Q? The eigenvalues of the matrix Q will be the same function of the lambda. Okay, will be the same function of lambda. That means the eigenvalues should be, what is the function of the matrix given? M cube, eigenvalue lambda cube, minus 4, M square, eigenvalue lambda square, minus 2M, M eigenvalue is lambda. Correct. So what is the first and second eigenvalue of A given? Okay, let's say this is lambda 1 and this is lambda 2. So the first eigenvalue of the matrix Q will be, apply this to the 5. So 5 cube minus 4 into 5 square minus 2 into 5. Okay, 125 minus 100 minus 10. So this is 15. And second one, this is an easier question only. Just values you have to substitute, minus 2. So minus 2 cube minus 4 into minus 2 square minus 2 into minus 2. So this is how much? Minus 8 and then minus 16, minus 24 and plus 4, minus 20, 15 and minus 20. 15 and minus 20, A and C. A and C. Recheck the calculations. Take the calculations patiently maybe. Okay, A and C. 15 and minus 20. What I'm getting? Minus 8. Correct, and that is 16, minus 16 and perfect, minus 20, it looks like correct, A and C. Okay, fine dear, let's move ahead to the next question then. Okay, let us move ahead to the further next question then. Okay, gate 23, 1 mark, good question this is again. If M is a arbitrary real n cross n matrix, which of the following matrices will have a non-negative eigenvalues? M is any real matrix, arbitrary. Okay, meaning any real matrix. Okay, which of the following matrix will have non-negative eigenvalues? That means either positive eigenvalue or 0. Okay, first talk about M square and M transpose square. This is easy. See, if M has the eigenvalue lambda, okay, what is the eigenvalue of M square? Just now we learned that it is going to be lambda square, correct? And then if M has the eigenvalue lambda, M transpose also has the eigenvalue lambda. So M transpose square will be lambda square. M transpose square eigenvalue will be lambda square. Okay. Now, will the M square and M transpose whole square, will they have positive eigenvalue? Lambda square, normally we think, okay, lambda square, square is always positive. For a real number, square is always positive. See, if lambda is real, okay, no doubt lambda square is always positive or 0, worst case. If lambda is 0, lambda square will be 0. Okay, but if lambda is imaginary, then, okay, say for example, lambda equal to I. What is lambda square? I square is minus 1. Na? Okay, so the lambda square can be negative also. So for A and D, we cannot surely say that eigenvalues are non-negative. Eigenvalue may be negative because eigenvalue are lambda square, and if lambda is imaginary, square will be negative. So A and D definitely not correct. A and D definitely not correct. Okay, what we want? We want the matrices having the eigenvalues which are non-negative. Non-negative means lambda should be greater than or equal to 0. That is what we want. Okay, positive or 0. Option number B and C. Now, how are we going to confirm option number B or C? Okay, M transpose. This is not only a function of M. We can't apply the property. I told you the property is for any function of M. This is M into M transpose, another matrix multiplied. Another matrix multiplied. Okay, so, let's talk about B or C by, taking any one example. Suppose M transpose. I'll explain you this by taking example. Okay, let's assume M as any square matrix. For simplicity, let's take a 2 cross 2 matrix. Let's take a 2 cross 2 matrix for simple to understand the result. A, B, C, D multiplied by A, B, C, multiplied by transpose. So AB will come here, CD will go here. Now multiply and see the result. Now multiply and see the result. Okay, multiply and see the result. Okay, so when you multiply, A into A square, first element, plus B into B square. A square plus B square. Next element, AC. Next is AC plus BD. Next, again CA, that is AC and plus BD. And last, C square plus D square. C square plus D square, correct? Right. This is okay. Now, when this is the matrix M transpose. Okay, so if you talk about the trace of this matrix, okay, also remember trace is sum of eigenvalues, and that will be A square plus B square plus C square plus D square. Sum of square means definitely positive. Then if you talk about the determinant, and the determinant of any matrix is also product of eigenvalues, so what is going to be the determinant? Let's solve this determinant cross multiplying A square in plus B square, okay, into, or why do I take it like this? Determinant can be taken this way. Determinant here, okay, is equal to determinant of M transpose. Let's apply determinant property. Even if you solve, you will get what I'm going to tell now. Okay, determinant of matrix A into B can be split. Determinant A, determinant B, and determinant of M transpose is always same as determinant of M. Okay, so determinant of M, okay, and A is the M is the real matrix. M is the real matrix, so determinant 100% real. How determinant? Determinant is formed by the numbers inside matrix. So there is no chance determinant is going to be imaginary. So determinant M square will be greater than equal to 0 because M is a real matrix. Okay, now you see, now what do I say? Okay, the sum of eigenvalues. Now what do I say? Sum of eigenvalues is positive. The product of eigenvalues is also positive. Now sum of two numbers and product of two numbers is positive. Both are positive. See, if product is positive, what I can say? The numbers are of plus plus or minus minus, either both positive or both negative. That is the only condition. But if both are negative, lambda plus plus, lambda 1 plus lambda 2 cannot be positive. So this concludes that, these two combined concludes that both positive, both eigenvalues positive, and hence we can say that B as well as C, similar discussions will go for C, B and C are both correct. B and C are both correct. B and C are both correct. Right here, next question. Correct. This was a good one. Some good analysis to be done here. Let's take the next question. Also jumping towards, the probability question here. Consider a random experiment where two fair coins are tossed and let A be the event that denotes head on both the throws, B be the event that denotes head on the first throw, and C be the event that denotes head on the second throw. Which of the following statement is or are true? Which of the following statements is or are true? Let's talk about this. Which of the following statements is or are true? Okay, so what are the events given? A be the event that denotes head on both the throws. Okay, two fair coins are tossed, and let A be the event that denotes head on both the throws. Okay, so A is directly the event given. B be the event that denotes head on the first throw. Okay, and C be the event that denotes head on the second throw. Okay, C be the event that denotes head on the second. So what is on the first is unknown. So what is the okay, let me complete the set B as first. Okay, what is the set B? H and unknown. So what is that unknown? Unknown in second coin. The second coin can also either give you a head or tail. So both the possibilities will take. So HH and HT, two cases will combine here. Coming to the set C, now this is question mark. Okay, so TH and TT. TH and TT. TH and TT. TH and TT, correct? Okay, so what are the probabilities of these events? Okay, when you talk about two coins, what is the sample space? Sample space will have 4 outcomes: HH, TH, HH, HT, TH or TT. Okay, what is the probability of HH? See, let me write down the probability of the A event. Okay, probability of head on any one coin is 1/2. So 1/2 each, 1/4. What is the probability of B? Okay, HT and HH and HT. Okay, so for any HH, it is 1/4. For HT, it is again 1/4. Same calculation. So 1/2. Similarly, probability of C also, let me write down 1/2. 1/4 plus 1/4. Okay. Okay, good. The second one is HH. Sorry, that's a typo error from my end. That is HH. Second one H only, na? Okay. Right, Srikanth, correct. Okay. Charanraj says the answer C here. Okay. Now, whether AB, AC, BC, which of them are independent? Okay. If two events are independent, then P of A intersection B should be PA into PB satisfied for sure. If two events are independent, P of A intersection B should be PA into PB for sure. Should be PA into PB for sure. Okay, Hovan says D. Only one options coming up right now. Let's see. Now, let's take the intersections. Now, next I will start taking their intersections. So, dear, what is A intersection B? Okay, let me write it here. What is A intersection B event? If I take the intersection, what is the common? HH is the only event common in A and B. HH is the event common. So, when you take A intersection B, it will only contain HH. When you take A intersection with the C, then also HH is the only common event. And when you take B and C, intersection of B and C, in these two sets also HH is common. Okay, so HH. So intersections are HH. But when you talk about probabilities, okay, probability of A intersection B is how much? Probability of HH is 1/4. Is it equal to PA PB? Is it equal to PA PB? PA into PB, 1/4 into 1/2 will be 1/8, not equal, dear. Then probability of A intersection C. Probability of A intersection means HH probability. HH is 1/4. Again, HH probability is 1/4, as I have already shown you. Is it equal to PA PC? I am talking about A intersection C. Is it equal to PA PC? Is it equal to the PA PC? Is it equal to the PA PC? Tell me, dear. Okay, so PA into PC, 1/4 into 1/2, not equal. Okay, P of B intersection C. P of B intersection C. Okay, 1/4. Okay, is it equal to PBPC? Is it equal to PBPC? Okay, 1/2 into 1/2 there. 1/2 into 1/2, yes. Yes, it is PB into PC because 1/2 into 1/2 is 1/4. This is correct. This is correct. So B intersection C. Probability B intersection C is, what I have not got is B intersection C probability is equal to PB and PC. That means B and C are independent. That is confirmed. B and C are independent. Then option number D. Okay, C is correct. What about D? If B and C are independent, if B does not depend on C, so we can also say probability of B given C. What is this? Conditional probability. Probability of B given C is equal to PB. Whether C happen or doesn't happen, it will not change the probability of B. That is the basic way of defining independent events. Okay, if B doesn't depend on C, the probability of B, whether C happens or whether it does not happen, see, if I don't know about C, what is the probability of B? PB. If C happens, what is the probability of B? It should be same because B does not depend on C. They are independent. Okay, so D is correct. Okay, so both C and D are correct, dear. C also correct, D also correct. Not only C, not only D. Check it out, okay? C and D both correct. C and D both correct. C and D are both correct. Right. Next question. C and D are both correct. Next question. Gate 24, 1 mark. A good question for 1 mark, I would say. This is a current year question, GATE 24. Current year question, GATE 2024. If x is a discrete random variable that is uniformly distributed over the set -10, -9, etc. up to 10, which of the following random variables is or are uniformly distributed? What is the meaning of this uniform distribution? Okay, x is a discrete random variable that is uniformly distributed. That means all the probabilities of x are uniform. Okay, what is the meaning of this uniform distribution? That probability x takes the value -10, or probability x takes the value -9, or whether it takes the value x equal to 0, or whether it takes the value x equal to 10, all of them are equal. Okay, and equal to how much? Equal to how much? So -10 to +10, how many values? 1 to 10, -1 to -10, 20, and include 0, 21. Okay, so if you see here, this will be total 21 values. Okay, so if all probabilities are equal, so each probability should be 1 by 21, so that sum of probabilities equal to the 1. That is still maintained. So that the sum of probabilities is still equal to the 1. Sum of probabilities is still equal to the 1. Still equal to the 1. Okay. Sum of the probabilities is still equal to the 1. Okay. Correct. Now, which of the following random variables is or are uniformly distributed? X square? Okay, x cube, x minus 5 square, x plus 10 whole square. Now see, what about x square? X has the values -10, -9, etc. up to 0, etc. up to the 10. Okay, so when you talk about x square, okay, whether it is -10 or +10, square will be one value. So the minimum value will be 0 square, then 1 square, then 2 square, then 3 square, up to 10 square, which is 100. Now, basically, no need to calculate if you know the concept of uniformity, but just to explain you, let me write down what is the probability x equal to 0? What is the probability x square equal to 0? This is x square. Okay. It is equal to probability x equal to 0, which is 1 by 21. But if I ask you, what is the probability that x square takes the value 1? X square, dear, can take the value 1 when x takes the value 1 or -1. Because for both of them, square will be 1. Na? X square is 1, so x can be plus or -1, any value. Okay, after square, I have only one value. Okay, so two cases are coming up here, 1 by 21 and 1 by 21, 2 by 21. Okay. Probabilities of different values of x square are different. Okay, the probabilities are not same. Not uniform. Not same means not uniform. The probabilities are not uniform for x square. Done it is. The probabilities are not uniform for the x square. The probabilities are not uniform for the x square. Next, what about x cube? Now, similarly, if I form x cube, see, -10 cube and +10 cube will be different. Okay, so x cube, -10 cube, -1000, -9 cube, -729, 0 cube, 0, 1 cube, 1, okay, 10 cube, 1000, because every value of x corresponds to a different value of x cube. Okay, probabilities will be same only. Probability here, x equal to -1000, okay, probability that x equal to -729, probability like that you take probability x equal to 0. Okay, so x equal to -10 corresponds to only one event, x equal to -10. This corresponds to -9. This is x cube actually. Probability x cube equal to 0 means probability x equal to 0, and these are all same. These are all same, means uniform. Okay, so x cube is uniform. Okay, x cube is uniform. That x cube is uniform. MSQ question. since it is MSQ question. Okay, x minus 5 square and x plus 10 square. Okay, hope you have got the concept. Hope you have got the concept now. Okay, if the concept is clear, dear, if the concept is clear, okay, see, A option is wrong, B option is correct, and what about C or D? What about C or D? Try C or D as homework. Okay, hope you have got the theme. Hope you have got the theme. Okay, let me know if there is any doubt right now. Let me know. Okay, so if you have got A and B theme, okay, A was definitely wrong, B is correct, C and D you have to try as homework. Try C as well as D. Both MSQ question, we have to be confirmed for every option. Try the C and D as the homework. Okay, fine. Try the C and D as the homework. Okay. Next question. Let's move ahead to the next question. Okay, hope you will do it. If there is any doubt, let me know right now only. For the function fx equal to e power x modulus sin x, x belong to the set of real numbers. Which of the following statements is or are true? Gate 23 2 marks question. Gate 23 2 marks question. Which of the following statements is or are true? The function is continuous at all x, function is differentiable at all x, function is periodic, function is bounded. See, fx is e power x is into modulus of sin x. Now, we all know, we very clearly know the sin x curve. It's a simple analysis only. It's a simple analysis only. Okay, what we primarily know is the sin x curve. Okay. Okay, but what I want is modulus of sin x. And what is the role of any modulus function? The negative values also converted to the positive values. Okay, negative values also converted to the positive values. The mod of minus 5 is 5, mod of minus 3 is 3. All will be converted to the positive value only. So if I have to define modulus of sin x function versus x, okay, only positive cycles we will get. Rectified sine wave, which we call it as the rectified sine wave also. Rectified sine wave. This is also still periodic. Okay. Then the probability will occur. Now you have to calculate. See, Hovan, what you have to do first, write down the values of x minus 5 whole square. Okay. And then write down the values of x plus 10 whole square. And see for which value of x they are coming. If they are repeated, if any value corresponds to two different value of x, then there the probability more. Okay. So there you will get the different probability and hence non-uniformity will come. Okay. Yeah. Come here to this question. Now, this is what is modulus of sin x. Okay. Which you can also call this as the sin x curve. Modulus of sin x, this is the minus sin x curve. Because for this portion, when you take the minus, then it goes to the plus, minus, minus, plus. Okay. Now, this is modulus sin x, but my question is asking e power x into modulus sin x. Okay, what is the e power x? That also we know. E power x, exponentially growing function. Exponentially increasing function. So, when I multiply both of them, see, to explain, you have drawn 4 graphs. Okay, but if you are clear about these functions, you can draw it in a single graph. Okay, modulus sin x to be multiplied by e power x. So what will happen? What will happen on the left side? See, e power 0 is 1. Okay, for the left side, e power x is less than 1. Okay, so left side, lesser amplitude will be there. Okay, right side, the amplitude of e power x is growing. This is periodic, but because of e power x exponentially increasing. Okay. So the amplitudes of this sine wave will also keep on increasing and increasing. Left side, it would be actually decreasing and decreasing. This is how the curve will be going to come up. Okay. Now, this is what is the final curve. This is what is the fx given to me, which is the exponential function multiplied by modulus of sin x curve. And very clearly, what are these points known as? Not only one of this point, what are these points known as? These are all known as sharp points where the nature of the function is suddenly changing. It was sin x and then it becomes minus sin x. Again sin x minus sin x. Where the nature or the definition of the function abruptly changes is a sharp point. And at every sharp point, function is continuous but not differentiable. This function is entirely continuous. I can draw it in a single go without taking my pen out of the paper. It is continuous. Okay. What is the sharp point? The function is continuous at the point, but left hand derivative not equal to right hand derivative. And the function is not differentiable. These are simple results, guys. You see the videos. If you are not clear about this, you can see my earlier videos on the calculus also, because at exam you have to go with the quickest method. You don't have to prove LHD, RHD. If you are able to see sharp point, what is a sharp point? Where the nature of the function abruptly changes. Okay, where the nature of the function, okay, there's a sudden change in the graph. Sin x, suddenly it changes. Okay, to minus sin x. Okay, so there what you can say, it is continuous but not differentiable. It is continuous but not differentiable. It is continuous but not differentiable. Okay, so the function is continuous for all x, correct? It is differentiable at all x? No. Okay, the option is telling it is differentiable at all x? No, it is not differentiable. At what points? I'll write down that. Okay, what are these points, dear? What are these points? This is 0, pi, 2 pi, 3 pi. We know that, na, these points. Okay, so it is not differentiable at x equal to n pi, where n can be any integer, positive, negative, anything. Okay, so it is not differentiable for all x. So B is wrong. A is correct. Is the function periodic? If they only ask modulus sin x, that is the rectified sine wave periodic. But now this is a exponent. This is increasing. Repetition is not there. Only increase. It is continuously increasing function. So C is also wrong. It is not periodic. Is it bounded? Is it always bounded? See, bounded means bounded for all values of x. If they don't specify any range. Okay, so is it bounded? No, it keeps on increasing, and finally it will tend to infinity. So we can't call it as a bounded function. So only option number A. It is the MSQ question. Now see, only A, and there have been other instances also, even in other subjects also. See, what is MSQ? IITs clearly say multiple select question where one or more than one option can be correct. They even specify one or more than one. So sometimes one can be correct. Here only one option correct. Here only one option correct. Sometimes only one can be correct. And here, yes, it is one option correct without a doubt. Okay. Without a doubt. Let me come to this question first. Let me come to this question. Consider this fx. Why not periodic? Because there is no, see, stranger, how the function is. Periodicity means the rectified sine wave, the nature, the values is repeating after every pi. Okay, but what happened when you multiplied by exponential function? Are the values repeating? Periodicity means repetition. The values are rather increasing. Periodicity means after every fixed interval, the repetition should occur. Okay, the repetition should occur. Yeah. Which of the following statement is or are true? Gate 23 1 mark question. Gate 23 1 mark question. Fx equal to x cube plus 15x square minus 33x minus 36. Okay. Which of the following statement is or are true? Fx does not have a local maxima. Fx has a local maxima. Fx does not have a local minima. Fx has a local minima. Simple question on maxima minima. Simple question on maxima minima. Okay. So, yeah. Let me start by taking the first derivative of it. Stationary points, f dash x is 3x square plus 30x minus 33 equal to 0. So cancelling 3 also, so x square plus 10x minus 11 equal to 0, so which should be factorizable as x plus of 11, x minus 1. Am I right? Yes, looks okay. So x is minus 11 and plus 1. These are two stationary points. Now, these two stationary points may be maxima, may be minima or point of inflection. For that, you can take the first or second derivative test. Let me simply take the second derivative test here. I only need to confirm maxima or minima. No increasing, decreasing zone required. Okay, so the second derivative will become 6x starting from here plus 30. Okay, now f double dash minus 11. If you take minus 11, Okay, it is minus 66 plus 30. That means negative. And when you take f double dash at the next stationary point 1, okay, so it is 6 plus 30 and that is positive. Wherever the second derivative is negative, that is a local maxima point. Correct. This is a local maxima point, and wherever the second derivative positive, it is a local minima point. So it has a local maxima also, it has a local minima also. B and D. Simple, simple. Yes, Hovant, correct answer. It is very simple. This one is simple. Let's move ahead to the next question. Let's move ahead to the next question. Here it is. Let ft be a real valued function whose second derivative is positive for minus infinite less than t less than infinite. The second derivative is positive for minus infinite less than the t less than the infinite. Minus infinite less than the t less than the infinite. Minus infinite less than the t less than the infinite. Okay, minus infinite less than the t less than the infinite. Which of the following statement is or are true? Which of the following statements is or are true? Tell me. Ft has at least one local minima. Ft cannot have two distinct local minima. Okay, or what is the story? See, second derivative is positive for all values of time. Minus infinite to infinite means all values of time, nothing left. Which of the following statement is or are true? Let's work it out here. Okay. See, it's a gate 24 correct. Why? It is mostly a conceptual question. It's mostly a conceptual question. It is mostly a conceptual question. Yeah. What are the answers coming up? AP political facts say that A and B. Now see, second derivative is positive for at least, for all values of time. Whether it has at least one local minima, ft cannot have two distinct local minima, ft has at least one local maxima. Now the option which is 100% wrong, okay, Hovant also says A, the option which is 100% wrong is it cannot have a local maxima, because for a local maxima, okay, for a local maxima, C is 100% correct, okay, because for a local maxima, okay, the second derivative, okay, which is given to you, the function is ft, the second derivative has to be negative, as we just took in the previous question. Second derivative has to be negative, okay, and second derivative is always positive, okay, is always positive, so it does not have a local maxima, and because it does not have a local maxima, it cannot have two local minima. Now option number B is related to it. Okay, why? Because if you want to have two minima, okay, there cannot be consecutive minimas. Similarly, there cannot be consecutive maxima. Okay, if there is a minima, there has to have a maxima and then only a next minima can come. Okay, right. So if you want to have two distinct local minima, minima, okay, so this has to be maxima. This is min, and this has to be maxima. But maxima is not possible here. Maxima is not possible here. That's what option number C I explained you. The B is also correct. Ft cannot have two local minima. Ft cannot have two distinct local minima. Are you clear? Ft cannot have two distinct local minima. Now Ft has at least one local minima, or minimum value of Ft cannot be negative. Why the minimum value of Ft cannot be negative? Okay. Acha, which of the following is or are true? B is true. It cannot have two distinct local minima. It has at least one local maxima. Wrong. Actually, C was wrong. I thought they are asking the false one. C is wrong. It has one local maxima. No. Okay, that's what I explained you. It cannot have two distinct local minima. That is correct for sure. Okay, that is correct for sure. Okay, now minimum value of ft cannot be negative. Who told you? Suppose you take an example, okay, ft which is equal to, suppose you take t square, simple example first. Okay, what is ft? T square. Okay. Okay, when you take the second derivative of it, 2t, and then again you take the derivative, it is always positive. Okay, it has a minima at t equal to 0. Parabolic curve can be taken. But you can take another example. Okay, ft, okay, maybe t square minus 2. ft maybe t square minus 2. Even the second derivative of this function will also be 2 because 2 doesn't appear. But when you draw, it is t square minus 2. Parabola starting from down level. Amplitude is down, 2 levels down. The minimum value cannot be negative. Who told you? There can be a minima, but minimum value of ft cannot be negative. Wrong. Okay, so C and wrong, D is wrong. Okay, B is correct. ft, it has at least one local minima, not generally correct. Okay, not generally correct. Not generally correct. It has at least one local minima. I'll take an example. If it is a polynomial function, if it was mentioned as a polynomial function, then this examples will work and definitely a minima is coming. Now say another example, fx is e power x. Okay, so second derivative, first derivative will also both be e power x, which is always positive. Because e is a positive number, e power x is always positive. E power x is always and always positive. E power x is always and always positive. Okay. Now, if I draw the ft curve only, if I draw the ft curve with respect to t, where is the local minima? Okay. It can have only one global minima, that also at undefined value of time, that is at minus infinity. What is the local minima? Local minima is something where the function is decreasing and then it starts increasing. The shape of the function, the nature of the function will change. This is what we mean by a local minima point. And at every local minima, the derivative must be 0. Okay, so, in such case, we don't have a defined local minima, right? So, it has at least one local minima, not necessary, not generally true. So, only B option is the correct option. Only B option is the correct option, not A. A, most likely, if we think with respect to polynomial function, looks like A correct, but not generally. Okay, the correct answer is B. Again, a type of MSQ question. Again a type of MSQ question. Okay. Again and again a type of MSQ question where only one option correct. Stranger, you're asking about C. What I'm telling, suppose you want to have one local maxima, but what is confirmed that if there is a local maxima, at the local maxima, second derivative must be negative. Okay, that is what we need. We need second derivative negative. But what the question says, for confirmed second derivative is always positive. Second derivative is always positive. Okay, that is the confirmation. Second derivative is always positive. So that means second derivative can never be negative and hence local maxima cannot be there. And that is the reason we cannot have two distinct local minima. Right? So B option was also correct then. B option was also correct. Another gate 24 question. Another gate 24 question. Consider the function ft max of 0 comma t whole square for minus infinite less than t less than infinite. Max of a comma b denotes the maximum value of a and b. Which of the following statement is or are true? Which of the following statement is or are true? Tell me. Max of 0 comma t whole square. Max of 0 comma t. First of all, let us talk about this function. Okay. Max of 0 comma t, then whole square we'll do later. Okay. Max of 0 comma t will be how? See dear, if I only want to draw a function, suppose which is ft equal to t, okay, or suppose some other function gt equal to t. So what is t? Y equal to x relation. Just like y equal to x relation. This will just be a straight line. if you only want to do a tree function, a ramp function, a straight line function. So dear, when t is greater than 0, t is more. Okay, this is maxima. But for the left hand side, t is less than 0. That means who will be maximum? Maximum of them has to be the answer. So dear, if t is positive, okay, greater than equal to 0, then the maximum value can be chosen to be t. But if you take the negative time means -1, -2, -3, so who will be maxima? 0 will be the maxima. 0 will be the maxima. This is about max of 0 comma t, and hence what is my function? And hence my function is the square of it further. My function ft is further square of it. That means my function ft should be parabolic t square for t greater than equal to 0 and 0 for t less than 0. How my function will look like? How my function will look like? Have a look into it. Okay, for t less than 0, the function will also be 0. For t less than 0, the function is also 0. Okay, but for t greater than 0, the function is t square, parabolic curve. Okay, we have to have a parabolic curve. This is what the function ft is. Okay, do you have any sharp point here? No, it clearly looks like a smooth variation. Okay, there is no edge point here. Okay, so now the options. Is the function not differentiable, or is the function differentiable and its derivative? See, if a function is differentiable, that automatically means its derivative is continuous. Its derivative is defined, then it is differentiable. So if it is differentiable, then this automatically goes correct. Fx is differentiable, but its derivative is not continuous. This option cannot be correct. Without checking, if a function is differentiable, that means that its derivative is a continuous function. Both are same thing. Okay. Ft and its derivative are differentiable. That is a different story. Ft differentiable and its derivative further differentiable. What is the derivative of it? What is the derivative of it? Okay, if I want to draw the derivative of it now, how are you going to draw the derivative of it? Okay, 0 derivative is 0. What about t square? The derivative of t square will be 2t, straight line. Okay, straight line. Here definitely there is a sharp point. You see, here you have a sharp point. Here you have a sharp point. Okay, here you have a sharp point. Okay, here you have a sharp point. Now you see, if you don't understand by sharp point, even if I take the derivatives, okay, see, what about the derivative f dash t? Okay, for right side it is 2t, for left side it is 0. Right side 2t, left side it is 0. Okay, but the derivative for t tending to 0, whether you talk about right hand derivative, so right hand derivative is 0, left hand derivative at t equal to 0. Okay, so what is the derivative? 2t, but at t equal to 0, the derivative is 0. Okay, the right side derivative is also 0, both are equal, the function is differentiable. Okay, the function ft is differentiable. Okay, whether the f dash d is differentiable? No, because I have a sharp point. Okay, I will show you by calculations also. Okay, is the function f dash t differentiable? So take the derivative again, that is f double dash. What is the f double dash? Okay, so what is the derivative of 2t? It is 2. For left side, 0 derivative is 0, but for right side it is 2. What is the LHD now? LHD, the derivative left side is 0. Derivative right side is 2. They do not match. So this function f dash t, which I already told has a sharp point, is further not differentiable. So that means now option by option. Is the ft not differentiable? Wrong. I told you ft is differentiable and hence its derivative is continuous. This is the same meaning only. Ft differentiable, derivative not continuous is not possible. ft and its derivative are differentiable? No. So again, only B option. Again, its derivative are differentiable? No. Its derivative is not differentiable. So D doesn't go, only B is going. The derivative, as you can see also, its derivative is continuous. There is no broken point here. So derivative is continuous. Okay, ft is differentiable, A wrong and D also wrong. ft and its derivative are differentiable. No. Yeah, no. Because we have to do the analysis for all values of time. So at t equal to 0, it is not differentiable. Okay, so only B. D is not correct. Just check it out once again, AP Political Facts. D, okay, ft and its derivative, the derivative being differentiable is failing at the origin. That is failing at the origin. Okay, so good analysis is involved here. So good analysis. Okay. Now, one more question, gate 22 based on maxima of two function. Okay, both are straight lines. So I'll give you this one as homework and you can comment your answers. You can comment your answers. Let me give you this question as homework. You can comment your answers there. It is continuous in its domain. It has a local minima at 2. It has a local maxima at 2 and it is differentiable on its domain. Okay, next question. Okay. Let's go to the next question then. This was already done, maxima, minima. This was a conceptual question, good one, 2024. Okay, gate 22, 1 mark, simple vector question. A very simple vector question it is. Okay, given the vector v, 4xy I cap plus 2x square minus y square, 2 variable 2d, is it 1d? No. Okay, is it incompressible? Is it irrational? It is not irrational, it's a wrong statement. It is irrotational. Typo error. Is it irrotational? And the acceleration experienced by the fluid particle is 0 at x equal to 0, y equal to 0. Let me calculate. First, let me start by the acceleration only. Okay, what is the acceleration? Rate of change of velocity, dv by dt, and v is a two variable function. So let me use the total derivative concept. Del v by del x into dx by dt plus del v by del y into dy by dt. That is the total derivative concept. And what is del v by del x? Derivative with x, 4y and then dx by dt. Plus del v by del y, derivative with y. Sorry, I missed one term. Okay, first if I talk about del v by del x. Okay, del v by del x. Okay, so 4y I cap and 4x j cap dx by dt and plus del v by del y, derivative with y. Okay, so 4x I cap and minus 4y j cap dy by dt. Now all terms directly have x and y and they are asking acceleration at 0, 0. At 0, 0, yes, all x and y, if you put 0, the acceleration will be 0. So D is correct. D is correct, A is wrong. Now, what is meaning of incompressible vector or irrotational vector? A vector is irrotational if the curl is 0. A vector is incompressible if the divergence is 0. If the divergence is 0. Okay, so let's check the divergence and curl of this vector. Okay, the vector is 4xy I cap. Okay, plus twice of x square minus y square j cap. Okay, so what is the divergence of v? Del dot v. Divergence, okay, del by del x of the x component. Del by del y of the y component. The y component is 2x square minus 2y square. Del by del x here, 4y. Del by del y here, minus 4y, 0. Correct? So yes, it is incompressible. Okay, divergence is 0. Del dot v I have calculated 0. Now what about curl? Del cross v. Is it also 0? Let's see. Let's comment. Okay, so what is the curl of this vector? What is the curl of this vector? I, j, k, del by del x, del by del y, del by del z, and 4xy twice of, or let me write down directly, 2x square minus 2y square, and there is no z component. So this is I cap. This is I cap. Del by del y, del by del z, both 0 here. J cap also will be 0, 0. Only k cap term will be obtained, perpendicular component obtained. Del by del x, 4x. Del by del y here, 4x. So again 4x minus 4x, 0. Curl is also 0. So yes, del cross V also 0. So the vector is irrotational. B, C, D are the three options correct here. The B, C, D are the three options which are very correct here. B, C, D are the three options which are very correct here. Okay. Let's move ahead to the next question. See, a simple GATE 24 2 marks question on some vector identities. On some vector identities. Okay, which of the following is or are correct? A GATE 2 mark question. Okay, please can you let me know the answer for this one? A GATE 2 mark question it is. Yes, guys, sorry. Let's continue. The three vectors are given to you, P, Q, and R, and which of the following is or are correct? Which of the following is or are correct? Okay. P cross Q cross R is equal to P cross Q cross R. Okay. See now, one observation first. Let me tell you before I solve it. Okay. See, general identities also exist here, but you know, I plus I is 2I, J plus 2J 3J, and K plus K is K plus K. Is it K plus K? I think there is a typo error. Just allow me a second here. I think there is a typo error here. I think there is a typo error for sure. GATE 24 question only, na? GATE 24 2 marks. Okay, let me check it out once. Let me check it out once. Okay, what I will do, dear, is better. Let's not waste time. I'll come back to it. Let me check the exact data. Let me be confirmed whether that identity is true or not, because I remember that. Let me give you the next question for the time being. Next question for the time being. Here it is. GATE 24 1 mark question. Which of the following complex function is or are analytic on the complex plane? Analytic on the complex plane. Is or are analytic on the complex plane? Okay, I'll just check that data once. Mm-hmm. Yes, I think, yeah, that was a typo error. I have the correct data now. I have downloaded the official paper. Okay, yeah, guys. So let's come to this answer first. Okay, which of the following is or are analytic? Polynomial. See, you don't have to check it every time. See, this is a polynomial, 100% analytic, and this involves a modulus function. This is not analytic. E power mod z will not be analytic. Now coming to this function, j imaginary part, j real part of z, that is jx, and imaginary part of z means y, because z is x plus jy. Okay, so if I just test option number A, okay, normally only real and only imaginary parts are also not analytic, but just let me show you. This is only jx. Okay, this is only jx, and when you compare to u plus jv, okay, considering as a complex function, real part u, imaginary part to v, okay, what is the Cauchy-Riemann equation? Del u by del x, okay, del u by del x, will it be equal to del v by del y? Okay, del v by del y. So this will be correct because u is 0 and v is equal to x. Okay, del u by del x and del v by del y both 0. But the second CR equation, del u by del y should be negative of del v by del x. Del u by del y should be negative. Now del v by del x will be 1 and here it is 0. This will not match and hence it is not analytic because CR equation will fail. Okay, CR equation will fail. Similarly, B also. Okay, you try, CR will fail. Okay, you can try out, CR will fail. So only option number D. Again MSQ question, but only D correct. Again MSQ question, but only D option correct. Again MSQ question, but only D option correct. Correct, dear? Yeah. So let me jump to the previous question. I have taken the correct data. Yeah, where is that one? Yeah. So what is that? Let me take the data here once again. Where is that paper gone? Gone. I plus j plus k. I plus 2j plus 3k. This is not even k. This is plus 3k. And 2i plus 3j plus 4k. Yeah. So there was an error here actually. There was an error here. Correct? See here. Now, dear. Okay. So that's what I was trying to highlight. There is a relation here. They are dependent. They are linearly dependent. R is P plus Q. Now, option number D is the direct vector triple product formula. No need to check anything. P cross Q cross R. Okay. P dot R into Q minus P dot Q into R. Okay. That is nothing but vector triple product. That is vector triple product. So this is going to be correct. D is anyways correct. Okay. D is anyways correct. Okay. Now, B option, okay, under the circumstances, okay, only B option to be checked. Again, dear, A and C to be checked by vector triple product. Okay, A will be wrong. Okay, I have to take, the time is already, 9:45 and I have to show you 2-3 more questions. So calculations, I hope you can do. Okay, this is to be checked by vector triple product. Okay, C also to be checked by vector triple product. Okay, so A and C, please solve by vector triple product formula. A and C, okay. Try by the vector triple product formula. Okay, this is the formula. D option is correct. Vector triple product formula. And once you solve by the vector triple product formula, A will be wrong, C will be correct. Now, if I talk about B option, R dot P plus Q, see, generally P cross Q it is. Generally, it may not look like correct because P cross Q dot R can be written as R dot P cross Q. Okay, but here it is Q cross P, and Q cross P and P cross Q are not the same. Here, R dot P cross Q under the condition R is how much? P plus Q. So this is P plus Q dot P cross Q. Now open the bracket. So P dot P cross Q. Scalar triple product, and in scalar triple product, whenever two vectors are same, okay, this is going to be P dot P cross Q plus Q dot P cross Q. And dear, this is a scalar triple product formula, and if any two vectors in scalar triple product same, here PP same, here QQ same, answer is 0. Right hand side, what is right hand side? Q cross P dot R, and R is again P plus Q. Solve it up similarly. Okay, Q cross P dot P, again scalar triple product, two vectors same. Q cross P dot Q. Okay, 0, 0. Answer will be 0. Answer will be 0. Correct? Answer will be 0. Yes, so both match. B option correct. Both of them are equal and equal to 0 here. Right. Equal to 0 here. Right. Next question. Tell me, which of the following differential equation is or are non-linear? Simple, 2 marks, but simple. If you have attended any of my differential equation class, you can observe simply what is a dependent variable xt. Dependent variable and the derivative multiplied together. That makes this equation non-linear. Dependent variable and the derivative multiplied together. See, what is the linear equation? Okay, linear means, okay, the dependent variable and all the derivatives must appear in the first degree and not multiplied together. Okay, the dependent variable, what is the dependent variable? Xt, and all derivatives of it, okay, must be linear. Okay, must be linear means must occur in first degree. Must occur in a first degree function, x power 1 function. Must occur in first degree, and also not multiplied together. So they are multiplied together. B is non-linear, and I am looking for non-linear. Here xt multiplied by independent variable, that is not a problem. Okay, so dependent variable and the derivative both are in the first degree, not multiplied together. Correct, this is linear. Here dependent variable xt and the derivative appearing in the first degree and not multiplied together. They can be multiplied by independent variable term. That is not a problem. So C also linear. See, I told you, linear term. Linear is a y equal to x power 1 function. Y equal to e power x is not linear. So this particular term contributes to non-linearity. Exponential function. Okay, so D is also non-linear. What term is non-linear? What term is making it non-linear? I have briefed you that term. Okay. Next question. Consider the following partial differential equation. A d2f by dx square plus b d2f by dy square equal to fxy. A, B are distinct positive real numbers. Select the correct combination of the values of the real parameters zeta and eta such that fxy equal to e power zeta x plus eta y is a solution to the given PDE. such that it is a solution to the given PDE. Tell me the correct answer here. Okay. Chalo. Let's take up this question. So basically, okay, the function is e power zeta x plus zeta y. What values of zeta and eta can be there so that the differential equation is satisfied? Partial differential equation. We can just try to satisfy it simply. Na? What is the big deal here? Okay, second derivative with x. See, what is the first derivative with x? Let me call it as fx. Okay, let me call this equation as a. Double derivative, we also call it as fxx, b, fyy equal to f. What is the first derivative? Exponential derivative is exponential only, but with the chain rule, the differential with x, zeta will be multiplied. And when you again differentiate, exponential derivative again exponential, again a zeta factor will come to zeta square. Okay, and what is this exponential function is f. Okay, so fxx, the second derivative will be zeta square f. Okay, and similarly, by the same logic, fyy will be how much? By the same logic, fyy, second derivative. So when you take the second derivative, again exponential function will repeat, but what is the coefficient that is going to come outside? Eta 2 times, so eta square f. Eta square f. Okay, so this given equation now looks like a, okay, fxx, that means zeta square into f, plus b, fyy, the second derivative is eta square into f equal to f. So f, if I take common and cancel, so a into zeta square plus b into eta square should be equal to 1. A zeta square plus b eta square should be equal to 1. A zeta square plus b eta square. Okay, so C is not correct. C is not correct. A into zeta square. So zeta square 1 by a. Eta square 1 by b. So a into 1 by a into 1 by b. This will give you answer 2. So D also not correct. C not correct. Okay, zeta equal to 1 by root a, eta 0, correct. So 1 by root a square will become 1 by a. 1 by a into a, 1. B correct. And 1 by root 2a. So zeta square 1 by 2a. Okay, eta square 1 by 2b. So 1 by 2 plus 1 by 2. A option correct. A option correct here. So this is satisfied by option number A and B. This is how a MSQ question is again found. Option number A or B. Option number A or B. Correct. Gate 22, 1 mark. Next one, current year Gate 24, 1 mark question. Simple one. What is the category of the equation? What is the category of equation? See, normally it's a second order equation. There's a classification, elliptical, parabolic, hyperbolic for linear second order partial differential equation. Okay, which we generally write down in the format of A, double derivative d2f by dx square, plus b, double derivative with xy d2f by dx dy, plus c, double derivative with y del 2f by del y square, plus d, del f by del x, plus e, first derivative terms del y by del y, okay, plus some constant f, okay, some constant f, or let me call it as the names may be confusing here. So let me give it the name of the constants as capital A, capital B, capital C. These are the coefficients, capital D, capital E, and suppose capital F. This is equal to 0. Okay, this is equal to 0 or any function. Let me call it as 0. Okay, what we actually calculate b square minus 4ac. And if b square minus 4ac is 0, then the equation is parabolic in nature. Then the equation is parabolic in nature. If it is less than 0, then the equation is elliptical. If it is greater than 0, then it is hyperbolic. Then it is hyperbolic. Elliptical, parabolic, hyperbolic. Elliptical, parabolic and hyperbolic. Correct. Okay. So what is the b square minus 4ac here? See, b, double derivative with x and y, that is not available. Minus 4, x is like a here, and double derivative with y, coefficient is y. So b square minus 4ac is minus 4xy. Okay, it can be only parabolic if x or y, any of them is 0, which is not in any of the option. Okay, now is it hyperbolic for x negative, y positive? See, x negative, y positive, so product will be negative, minus minus plus. So yes, for positive it is hyperbolic. Option number A correct. Parabolic not correct. X equal to 0 is here, but if x equal to 0, it will become parabolic. So C not correct. If x and y are both positive, the overall product will be negative, and yes, overall product negative, it will be elliptical. A and D are the correct options here. A and D are the correct options here. Okay. So this is a standard result of a linear. Okay, this is a standard result of a linear second order partial differential equation. The standard result of a linear standard second order partial differential equation. Okay guys, so with this quick reminder that tomorrow 12th January, do not miss the very important All India Mega Free Mock Test. Okay, that is going to be conducted by Om Institute for EC and EE online as per the GATE examination. Okay, all the students will get All India ranking and also a real-time feel of examination and complete solutions for all the questions. The top 5 performance will be getting exciting prizes. Okay, so registration is important. The test is free. Even the registration is free. Scan the QR code. Okay, and you can get yourself registered. Or for any queries, you can visit ominstitute.com or call this number 95156 And also, guys, tomorrow we are seeing you, the team of Om. Tomorrow we are seeing you, okay, at 7 p.m. on the same channel. Yes, guys, if you want to have continuous updates about GATE 25 or any other important sessions happening, do not forget to subscribe to the channel. If you are not yet subscribed, do subscribe the channel so that you get all the regular updates. And tomorrow 7 p.m. okay, let's talk about all the upcoming plans for the GATE aspirants. Okay, a lot of New Year gifts, and let's also begin up the revision mega marathons, and we'll also tell you the schedule of the revision mega marathons. Okay, so tomorrow 7 p.m. please join us. Okay, and let's discuss something important. Okay, yeah, so today's PDF I'll share you in the Telegram as always. Okay, as always it will be a password protected and the password will be MSQ session. So let me keep the password as MSQ randomly. I think everything in small, MSQ. Okay, the PDFs are password protected. If you have watched, you get the PDF, and the password is MSQ. Is MSQ. Okay, dear. So that's it from my end. Thank you, and see you tomorrow at 7 p.m. And do not forget to attempt in the All India Free Mega Mock Test. Bye bye. Thank you. Good night. Stay safe and hope you have enjoyed. If you have attended the session, put your attendance, and that is by simply hitting a like button. Okay. Thank you.